Hello, my name is Michaela DeForest, and I'm a developer here at the ATS Group and Galileo Suite. Welcome back to the second part of a three-part series on monitoring Kubernetes and cloud-native applications with Zabbix. In this part, we'll explore the functionality provided by the Kubernetes integration in Zabbix and discuss some use cases. So let's get started. In the last part, we had discovered each node and the kubelet associated with it. Because the cluster we used was a managed EKS cluster, we didn't discover control plane components because those are managed by AWS and not directly available through the API. For the sake of demonstrating the full capabilities of the integration, we'll continue with a cluster that was created using the kubeadm utility. In the latest version of Zabbix, control plane components are discovered via node labels that are added only for clusters that are created with kubeadm. Depending on your setup, you may be able to add the same node labels to your own control plane nodes, or modify the templates to use your specific labels. In the demo cluster I'm monitoring here, we have 4 worker nodes and 1 master node. The control plane is running entirely on the master node. Let's start out by talking about discovery because this feature is the backbone of Kubernetes monitoring in Zabbix. Zabbix discovers each node and creates 2 hosts to represent them in the cluster. The first host attaches the Linux by Zabbix agent template to it, and the second attaches a custom kubelet template to it. Zabbix also creates items for most standard objects like pods, deployments, replica sets, jobs, cron jobs, and so on. Here you can see the 4 discovered worker nodes and the template attached to it. This is going to give you the metrics about the machines running in the cluster. Looking at the dashboard for one of our workers, you can see data such as system load, CPU usage, and memory usage. Zabbix will also collect metrics related to the nodes, but specific to Kubernetes. Let's go over to the latest data and filter by the Kubernetes node host. Now you can see metrics like allocatable CPU available to pods and the capacity of the node for memory. If I head over to problems, you can see I'm getting an alert that I have allocated too much CPU on each of my worker nodes. This could be an indication that I should increase my capacity if I'm assuming that the memory and CPU limits that I set for pods are accurate. The Kubernetes integration also monitors object states. In my opinion, this is the most important monitoring capability of Zabbix. As a best practice, you should definitely be monitoring and alerting on critical status changes within the cluster. Let's take a look at some of the items that Zabbix can trigger on. Here you can see triggers related to the health of a pod. There are also some triggers for when certain conditions are detected by the nodes like memory or CPU pressure. Zabbix discovers objects like pods, deployments, and replica sets and triggers on object states such as pods that are not up or deployments that do not have the correct number of replicas up. Let's head over to the terminal to walk through an example of this. Here you can see the Kubernetes dashboard deployment running in my cluster. I have set up with 3 replicas, as you can see here. Now if we go back over to Zabbix, let's find state data for this deployment. I'll search for deployment Kubernetes dashboard in latest data. Now looking here, we can see that everything looks good. There are 3 replicas available out of the 3 that are desired. If we go back to our terminal, you can see that this matches the 3 out of 3 seen in the deployment description output. Now let's change this by creating an issue with one of the pods. I'm going to copy one of the pod names and run kubectl edit pod, and then paste in the pod name. Let's look for the image option, and we'll change the image tag to something invalid like invalid.tag. So I'm going to go over here and change this tag to invalid.tag, for example. Okay, let's save that now. And this is going to cause the pod to fail because it can't pull the images anymore. So if I just run kubectl get pods again, you're going to see that one of the pods is no longer ready, and it's giving this crash loop back off, which can mean that the image was not able to be pulled. Let's go back to Zabbix and see if anything has changed. Okay, now looking at the data, there has been a change. The number of available replicas is only 2 now, and the number of unavailable replicas is up to 1. Under problems, you'll see we have 2 new problems. Both are alerting to the fact that there is a mismatch in the number of replicas for the dashboard and the number of desired replicas. Now, if we go back to our terminal and edit this pod again and change that image tag back to what it was before, which was v.v2.7.0, and we'll save that, and we'll just verify with kubectl get pods, and you see that that pod is now running again. So when we go back to Zabbix, we should see that those problems go away. And there you go. You can see that the problems are now resolved and how quickly that happened too. We're immediately notified that there was a change in the desired state. The Kubernetes template offers so many metrics and triggers, pretty much anything you've seen using Prometheus and Alert Manager. It's also pretty easy to create new items if you have experience with Zabbix and can navigate the kubestate metrics and Kubernetes APIs. This is an example of the output from the kubestate metrics API. Unlike a lot of APIs, you'll see that the output is not in JSON format. That's because the kubestate metrics API uses the Prometheus data model to supply metrics. As you get comfortable with Kubernetes monitoring in Zabbix, you may want to parse out your own metrics from kubestate metrics and create new items. In the next video, we will learn how to monitor applications with Prometheus in Zabbix.